Hello, everybody. It's me, Code Talker Leader, for another episode of the starting out with Python. We are here now with the part six, and we are in the third chapter of the book. We're doing booleans, logic, and also if statements. So we got here with the comparing strings. So we're going to compare some statements all together, and also we did um, two other the first two exercises from the chapter. So without further ado, oh, sorry, let me silence my phone. Without further ado, let's get going with the rest of the chapter. 3.3 Comparing strings. Python allows you to compare strings. This allows you to create decision structures that test the value of a string. You saw in the preceding example how numbers can be compared in a decision structure. You can also compare strings. For example, look at the following code. Name 1 Mary, name 2 Mark. If name 1 is equals to name 2, print the name are the same. Else print the names are not the same. The equals operator compares name 1 and name 2 to determine whether they are equal. Because the strings Mary and Mark are not equal, the else clause will display the message the names are not the same. Let's look at another example. Assume that month variables reference a string. The following code uses the not operator to determine whether the value referred by month is not equal to October. If a month is not equal to October, print this the wrong time for Oktoberfest. Program 33 is a complete program demonstrating how two strings can be compared. The program prompts the user to enter a password that determines whether the string entered is equal to Prospero. Okay, let's go. I'm going over here. Mm, mm, uh, Okay. All right. So the program name is password.py. Program compares two strings. Oh my gosh. Oh my god. Please stop. Get a password from the user. Password equals input. Enter the password. Uh-huh. Now determine whether whether the correct password was entered. Oh, sorry. If password is equals to Prospero, print password accepted. Else print sorry, that is the wrong password. So now we go for run Python file, and in here we see enter the password. So go for Prospero, so password accepted. Okay, now let's run the code again. Go for example Prospero. Sorry, that is not the password. Okay. Uh-huh. String comparison are case sensitive. For example, the strings Saturday and Saturday are not equals because the S is lowercase in the first string. That's what I did basically with Prospero. Yeah, exactly. Okay. Other string comparisons. In addition to determining whether the strings are equal or not equal, you can also determine whether one string is greater than or less than another string. This is a useful capability because programmers commonly need to design programs that sort strings in some order. Recall from chapter 1 that computers do not store characters, such as A, B, C, and so on, in memory. Instead, they store numeric codes that represent the character. Chapter 1 mentioned that ASCII, American Standard Code for Information Interchange, is a commonly used character coding system. You can see the set of ASCII codes in Appendix C, but here are some facts about it. The uppercase characters of A through Z are represented by the numbers 65 through 90. The lowercase characters through to lowercase z are represented by the number 97 through 122. While the digits 0 through 9 are stored in memory as characters, they are represented by the numbers 48 through 57. For example, the string A, B, C, 1, 2, 3 will be stored in memory as the code 97, 98, 99, 40, 49, 50, and 51. A blank space is represented by the number 32. In addition to establishing a set of numeric codes to represent characters in memory, ASCII also establishes an order for characters. The character A comes before the character B, which comes before the character C, and so on. When a program compares characters, it actually compares the codes for the characters. For example, look at the following if statement. If lowercase a is greater, no, is smaller than lowercase b, the letter A is less than the letter B. Uh-huh. Okay. Mm-hmm. Mary and Mark. Oh, okay, okay, okay. Oh, interesting. Okay. Uh-huh. Okay, if one of the strings in comparison is shorter than the other, only the corresponding character will be compared. If the corresponding character are identical, then the shorter string is considered less than the longer string. For example, suppose the strings high and high were being compared. String high would be considered less than high because it is shorter. Okay, short names, we go with the short names here. Program short names.py. This program compares strings with the operator get get two names from the user. Okay, get two names from the user. Okay, so we go here for name name one equals input. Enter a name, last name first. Name two equal input. Enter another name. Uh, Last name first. Display the names in alphabetical order. Print Here are the names listed alphabetically. If name one less than name two, print name one, print name two. Else print name two, print name one. We save, we run Python file, enlarge this window. So our name, last name first, it's gonna be, how about Garrison? First name, it's gonna be Joseph. Garrison Joseph. Okay, let's try it again. Start again. So we go for uh, Egan Hammer. Egan Hammer. Okay. Let me see something. How about if we go for example, Fum, or how to call it name? Can I? Oh, Booth Richard. Richard Booth. Okay, all right. Yeah, that's cool. And look at that, guys. We reached the checkpoint. I'm gonna give three, two, one, and that's the other part of the checkpoint. Same as the 12. It's part of the 12. What would the following code display? All right. Let's go into nested decision structures and the if statement. All right. So it says as follows. Remember, I'm going to try today to do an hour long. We are 13 minutes in for the 5 more minutes. Concept. To test more than one condition, a decision structure can be nested inside another decision structure. In section 3.1, we mentioned that a control structure determines the order in which a set of statements execute. Programs are usually designed as a combination of different control structures. For example, figure 310 shows a flowchart that combines a decision structure with two sequence structures. With the decision structure, start, go to the window, read thermometer. Okay, okay. Go to the window, read thermometer, code outside. If it's true, we're a code. False, open the door, go outside, end. Okay. The flowchart in the figure starts with a sequence structure. Assuming you have an outdoor thermometer in your windows, the first step is go to the window. The next step is read thermometer. A decision structure appears next, testing the condition code outside. If this is true, the action where code is performed. Another sequence structure appears next. The step open the door is performed, followed by go outside. Quite often, structures must be nested inside other structures. For example, look at the partial flowchart in figure 311. Okay, if it's code outside, true, wear a coat, wear a hat, wear a glove. Sequence structure. Okay, so you're nesting the code, the hat, and the gloves as well. You can also nest decision structures inside other decision structures. In fact, this is a common requirement in programs that need to test more than one condition. For example, consider a program that determines whether a bank customer qualifies for a loan. To qualify, two conditions must exist. The customer must earn at least 30,000 per year. The customer must have been employed for at least 2 years. Figure 312 shows a flowchart for an algorithm that could be used in such a program. Assume the salary variable is assigned to the customer's annual salary, and the years on job variable is assigned the number of years that the customer has worked on his or her current job. So we're going for salary greater or equal to 30,000. If it's true, years on job. If it's false, you must earn at least 30,000 per year. Okay, but if it's true, go years on job is greater or equal than 2. If it's false, you must have been in your current job for at least 2 years to qualify. True, you qualify for the loan. Okay, let's go for program 3.5. This program is called Loan Qualifier. Loan, not load. This program determines whether a bank customer qualifies for a loan. So minimum salary is equal to 30,000. This is the minimum annual salary. Also have minimum years equals 2. I go for the minimum years on the job. Get the customer's annual salary. Salary is equals to float input. Enter your annual salary. Get the number of years on the current job. Years on job equals integer input. Enter the number of years employed. Determine whether the customer qualifies. If salary is greater or equal than minimum salary, if oh my gosh, sorry, JavaScript get me fucked up now. Years on job is greater than minimum years. And let me do something here. Let me print this before. Okay. You qualify for the loan. Okay. Else print you must have been employed for at least minimum years to qualify. Else, because this else print you must earn at least format mean salary per year to qualify. Zip. Okay, we save the file, we run the code, and we see enter your annual salary. Let's see. We earn, for example, $58,000. That is way more. There you go, right? Yeah. Number of years employed, 4 years. How about that? No, 3 years. To qualify for the loan. All right. Let's run it again. Let's say, for example, we do 34,000, but we are just 1.5. Oh, true. It's just an input. God damn it. Okay, 34,000, but we are just 1 year over there. You must have been employed for at least 2 years. Okay, cool beans. Cool beans. Let's read out. Look at the if else statement that begins in line 15. It tests the condition salary. If this condition is true, the if else statement that begins in line 16 is executed. Otherwise, the program jumps to the else clause in line 22 and executes the statement in lines 23 through 25. It's important to use proper indentation in a nested decision structure. Not only is proper indentation required by the Python interpreter, but it also makes it easier for you, the human reader of your code, to see which actions are performed by each part of the structure. Follow these rules when writing nested if statements. So each else clause is aligned with its matching if clause. Okay, yeah, indentation in Python is very important. Make sure the statements in each block are consistently indented. The shaded parts of figure 14 show the nested blocks in the decision structure. Okay, okay. Testing a series of conditions. In the previous example, you saw how a program can use nested decision structures to test more than one condition. It is not uncommon for a program to have a series of conditions to test, then perform an action depending on which condition is true. One way to accomplish this is to have a decision structure with numerous other decision structures nested inside it. For example, consider the program presented in the following in the Spotlight section. We're not going to use in the Spotlight section, but you guys can read it anyway. Dr. Suarez. Okay. Okay. All right. Okay. Greater. Okay, we're gonna do it anyway. Bring it to me, Mr. Suarez. So this program is called greater.py. This program gets a numeric test score from the user and displays the corresponding letter grade. Uh, Named constants represent the grade thresholds. I'm going to get this one over here for now. There we go. So A score equals to 90. B score is equals to 80. C score is equals to 70. D score is equals to 60. Get a test score. So now go here, get a test score from the user score integer input, enter your test score. Now determine the grade. If score is greater or equal, then a score print your your grade is A. Else, if score is greater or equal than B score, print your grade is B. Else, if score is greater or equal than C score, print your grade is C. Else, if score greater than D score, print your grade is D. Else, else print print your grade is F. See me after class. That is my flair, okay? I put it in. It's not in the book. See me after class. All right, so we saved the file. We saved the file right there. We are going to run the Python file. I'm gonna get here, enter your test score. My test score is 89, sir. Your grade is B. Let's try it again. Let's try it again. Run Python file. How about lower is 46. Your grade is F. See me after class. Let's go. All right. Now this is important. The if else statement. Even though program 36 is a simple example, the logic of the nested decision structure is fairly complex. Python provides a special version of the decision structure known as the if else statement, which makes this type of logic simpler to write. Here's the general format of the if else statement. If condition 1 if condition 1, 7, 7, etc. If condition 2, 7, 7, etc. Insert as many elif clauses as necessary. Else, when the statement executes, condition 1 is tested. If condition 1 is true, the block of statements that immediately follow is executed, up to the elif clause. The rest of the structure is ignored. If condition 1 is false, however, the program jumps to the very next elif clause and tests condition 2. If it is true, the block of statements that immediately follow is executed, up to the next elif clause. The rest of the structure is then ignored. This process continues until a condition is found to be true, or no more elif clauses are left. If no condition is true, the block of statements following the else clause is executed. The following is an example of the elif else statement. This code works the same as the nested decision structure in lines 14 through 26. Okay. Okay. So the else is the F because the elif score is, which makes sense because we use the else and then the if statement in each of the grades. All right. I notice the alignment in the indentation, blah blah blah. Elif statement is never required because its logic can be coded with nested if-else statements. However, a long series of nested if-else statements has two particular disadvantages when you are debugging code. The code can grow complex and become difficult to understand. That is true. Because of the required indentation, a long series of nested if-else statements can become too long to be displayed on the computer screen without horizontal scrolling. Also, long statements tend to wrap around when printed on paper. Okay. The logic of an if else statement is usually easier to follow than a long series of nested if else statements. And because all of the clauses are aligned in an if else statement, the length of the lines in the statement tend to be shorter. The checkpoint here, checkpoint 3.33, 3.13, convert the following code to an if else statement. Okay. That is your check. Wow, that is a very short checkpoint. We are in the 33 mark. More, just 30 minutes more to go. Okay, let's go. Logical operators. The logical and operators and the logical or operator allow you to connect multiple Boolean expressions to create a compound expression. The logical not operator reverses the truth of a Boolean expression. Python provides a set of operators known as logical operators, which can be used to create complex Boolean expressions. Table 3.3 describes these operators. And the operator connects two Boolean expressions into one compound expression. Both sub-expressions must be true for the compound expression to be true. Or the OR operator connects two Boolean expressions into a one compound expression. One or both sub-expressions must be true for the compound expression to be true. It is only necessary for one of the sub-expressions to be true, and it does not matter which. The NOT operator is a unary operator, meaning it works with only one operand. The operator must be a Boolean expression. The NOT operator reverses the truth of its operand. If it is applied to an expression that is true, the operator returns false. If it is applied to an expression that is false, the operator returns true. Okay. The AND operator. The AND operator takes two Boolean expressions as operands and creates a compound Boolean expression that is true only when both sub-expressions are true. The following is an example of an if statement that uses the AND operator. If temperature is less than 20 and minutes greater than 12, The temperature is in the danger zone. In this statement, the two Boolean expressions, temperature 20 and minus 12, are combined into a compound expression. The print function will be called only if the temperature is less than 20 and minutes is greater than 12. If either of the Boolean sub-expressions is false, the compound expression is false and the message is not displayed. Table 3.5 shows a truth table for the AND operator. The truth table lists expressions showing all the possible combinations of true and false connected with the AND operator. The resulting values of the expressions are also shown. True and false and true, false and false, true and true. As the table shows, both sides of the AND operator must be true or the operator to return a true value. The OR operator. The OR operator takes two Boolean expressions as operands and creates a compound Boolean expression that is true when either of these expressions is true. The following is an example of an if temperature is. Oh, okay. I believe that's Fahrenheit or not. The print function will be called only if temperature is less than 20 or temperature is greater than 100. True or false is true, false or true is true, false or false is false, and true or true is true. The short circuit evaluation. Both the and or operators perform short circuit evaluation. Here's how it works with the AND operator. If the expressions on the left side of the AND operator is false, the expressions on the right side will not be checked because the compound expression will be false if only one of the sub-expressions is false. You would waste CPU time to check the remaining expressions. So when the AND operator finds that the expression on its left is false, it short circuits and does not evaluate the expression on its right. Here's how short-circuit evaluation works with the OR operator. If the expression on the left side of the OR operator is true, the expression on the right side will not be checked because it is only necessary for one of the expressions to be true. It would waste CPU time to check the remaining expressions. The NOT operator. The NOT operator is a unary operator that takes a Boolean expression as its operand and reverses its logical value. In other words, if the expression is true, the NOT operator returns false, and if the expression is false, the NOT operator returns true. The following is an if statement using the NOT operator. If not temperature, maximum temperature, okay. Note in this example, we have put parentheses around the expression temperature. This is to make it clear that we are applying not operator to the value of the expression temperature greater than 100, not just to the temperature variable. Okay. The long qualifier program we visited. Okay. Um, okay, we have the long qualifier 2. This is the program 7, 3.7.5. So it is the long qualifier 2 pi. That's the name. Oh my gosh. I'm still, you know, trying to get used to my new keyboard. Program, see. Okay. Minimum salary is equals 3,000. Years employed. Determine whether the customer qualifies. Salary greater or equal minimum salary, and years on job equal minimum years. Print. You qualify for the loan. Else, print. You do not qualify for this loan. I'm just gonna go run Python file. 57. 3 years to be equivalent for the loan. And if we go for example, 34,000, 1 year only, you do not qualify for the loan. Too bad. The if-else statement in line 15 through 18 tests a compound expression salary and years in job. If both expressions are true, the compound expression is true and the message you qualify for the loan is displayed. If either of the expressions is false, the compound expression is false and the message you do not qualify for this loan is displayed. A careful observer will realize that program 377 and program 35, but it's their equivalent if the user does not qualify for the loan. Program 3.7 displays only the message you do not qualify for this loan, whereas program 3.5 displays one of two possible messages. True. Yet another loan qualifier program. Suppose the bank is losing customers to a competing bank that isn't as strict about to whom it loans money. In response, the bank decides to change its loan requirements. Now customers have to meet only one of the previous conditions, not both. Program 3.8 shows the code for the new loan qualifier program. So loan qualifier 3. Program 8.py. We close this. It is called loan qualifier 3.py. This program determines whether a bank customer qualifies for a loan. Minimum salary, the minimum annual salary, minimum years to the minimum years on the job. Get the customers annual salary float input their annual salary, get the number of years on the current job. Years on job is equals to integer input, enter the number of years employed. Determine whether the customer qualifies. Salary, minimum salary, or years, job, mm, years, print, you qualify for the loan. Print, you do not qualify for this loan. Okay, okay, let's run the code. Uh, oh, uh, uh-oh, uh-oh. Okay. Salary is 35. Mm-mm. One. Comfortable. Let's go. Okay. That's super good. That's super good. Doo-doo-doo, 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 doo-doo-doo. Checking numeric ranges with logical operators. Sometimes you will need to design an algorithm that determines whether a numeric value is within a specific range of values or outside a specific range of values. When determining whether a number is inside a range, it is best to use the AND operator. For example, the following if statement checks the value in x to determine whether it is in the range of 20 through 40. If x is equals or greater than 20 and x is less or equal to 40, the value is in the acceptable range. The compound Boolean expression being tested by this statement will be true only when x is greater than or equal to 20 and less than or equal to 40. The value in x must be within the range of 20 through 40 for this compound expression to be true. When determining whether a number is outside a range, it is the best to use the OR operator. The following expression determines whether x is outside the range. It is important not to get the logic of the logical operators confused when testing for a range of numbers. For example, the compound Boolean expression in the following code would never test true. Mm, okay. Obviously, x cannot be less than 20 and at the same time be greater than 40. Checkpoint, checkpoint. We got checkpoint. Okay. Assume the variables I to mm, okay. Boolean variables. All right. A Boolean variable can reference one of the two values true or false. Boolean variables are commonly used as flags, which indicates whether a specific condition exists. Okay, I think we are going to reach the end of this video right now. I know it's not actually 60 minutes, but 51 minutes is fairly acceptable to say, hey, I just did an hour of work of or study in Python. So, with that being said, we're gonna let the course be done here, and the next week we're gonna continue with the same hour range. So yeah, expect more. I think I'm gonna put my Python courses, of course, on Monday. On Tuesday, I'm gonna give space for the C sharp courses to be implemented. And then in Wednesday, it's gonna be JavaScript. I think that's the schedule that we're gonna have. Python Monday, C sharp, how you call it, Tuesday, and JavaScript Wednesday. And then Wednesdays, Friday, Saturday, and Sunday is gonna be potpourri. If I want to upload something, I will. So with that being said, thank you very much, guys. Click like, subscribe, and see you guys next time for more coding. Bye bye.